Okay, so this is the Algebra 2 review for the test tomorrow. Okay, so first one, rewrite each set in the indicated notation. So number one, set builder notation. Okay, so remember, set builder notation, we use our brackets, and we always put x first, and then we basically like your inequality notation. So in this case, I'm going to say x is greater than or equal to -5. Okay, you could also do, if you want to do it a different way, you can do clear x, and you can say -5 is less than or equal to x, which is less than or equal to infinity. Oh, that's supposed to be an infinity sign. So it doesn't matter either way. It just depends on the teacher you have and the method you like, but either one would be fine in that case. Infinity, there we go. Okay, so that's set builder notation. If you get confused at looking at this, then draw yourself a picture on your number line. Okay, so here's my number line, -5. It's a bracket, so it's a closed circle, and then it's going to infinity, so that's going this way. Okay, that can help you figure out, okay, x is greater than, this arrow matches this arrow. Okay, number two, interval notation. So interval notation, you have a start, you always work left to right. So I'm going to start here at +1. It's an open circle, so it's a parenthesis. And comma, I end at 5. It's a closed circle, so it's a bracket. Number two, again, if you get confused, draw it on a number line. Okay, so -2, open circle, going towards -infinity. +5, open circle, going towards +infinity. Okay, so set builder notation. Brackets. So I'm going to say x is less than -2, or x is greater than +5, and then close bracket. Okay, number four, interval and set builder notation. So x cannot equal 8. If I was to draw that on a number line, at 8, there would be an open circle, and everything else is shaded. Okay, so interval notation, -infinity, because I'm coming from the left, -infinity up to +8, parenthesis, or 8 to infinity. So I start at 8 and I go to infinity. And then set builder notation, bracket, x is less than 8, or x is greater than 8, close bracket. Okay, number 5, evaluate for f of -3. So I'm plugging in -3 into the x's here. So f of -3 equals 3 times -3 squared minus 4 times -3 plus 2. So you're following order of PEMDAS. So this becomes 3 times 9 plus 12 plus 2, 27 plus 12 plus 2, which is 41. And number 6, same thing. So f of 2/3 equals 3 times 2/3 squared minus 4 times 2/3 plus 2. Okay, so you've got a lot of fractions here. So I'm going to square this first. 3 times, you square the top, square the bottom. 4/9 minus, this is 4/1, 8/3 plus 2. Okay, I want to multiply this out right here. This is 3/1. So 3 and 9 can reduce, and I have 4/3. So 4/3 minus 8/3 plus 2. Now, actually, I'm going to change that to 2/1. I'm going to change it to have a denominator of 3, so it's like these. So I multiply by 3 on top and bottom. That becomes 6/3. So plus 6/3. Okay, and then I'm just going to add. 4 minus 8 is -4. -4 plus 6 is 2, so 2/3 is my answer. Okay, number 10, domain and range. So domain, we're going to go left to right. So my farthest x value here is 1, 2, 3, 5, -5. Closed circle, so it gets a bracket. And my farthest right value is 1, 2, 3, 4, 5, +5. An open circle, so parentheses. Range, I'm going to go bottom to top. So lowest y value to highest y value. So my lowest y value is at 0. It's a bracket because it's a closed circle. My highest y value, 1, 2, 3, 4, 5, is at 6. It's an open circle, so it gets a parenthesis. It says determine whether the relation is a function, so that's a vertical line test. I did a vertical line test anywhere on here. Yes, this is a function. Okay, number 11, domain and range. So domain. This right here keeps on going. So this is my, and then this one keeps on going. So for domain, it looks like it's at about, I'm going to say -2.5. And that's a parenthesis. It's going to keep on going up and up and up and get closer and closer and closer to this. Now as I go to the right though, it keeps on going. So that's going to infinity, which gets a parenthesis sign. And the range, I'm going to start bottom to top. So this looks like it's at maybe -2.5 as well. Again, a parenthesis, and going up to positive infinity. Is the relation a function? No, because if I draw a vertical line here, it passes more than once, so not a function. Okay, number 12, domain. So the farthest left value is -3, farthest right value, +3. So -3 to +3. Both get parentheses because they're open circles. Lowest y value is -2, highest y value is +4. So range is parentheses -2 to 4, close parentheses. And yes, it's a function. It passes the vertical line test. Okay, number 13, domain. My farthest x value is -1. My farthest right x value is 5. So bracket, -1, 5, bracket, because it's going through that point. Range, my lowest y value is -3. My highest y value is +3. So range, bracket, -3 to 3, bracket. And no, it's not a function. If I draw a vertical line, it passes through more than once. All right, second page. Okay, number 14, so composition of functions. Okay, remember on these, you're basically substituting a whole function into the f. So I'm going to take the whole thing for g and put it into f. Okay, so up here at the top, I'm going to take this whole thing and put it into this x. So I have this equals 7 minus 2 times 4/5 x plus 3. Okay, distribute the -2. So 7 minus 8/5 x minus 6. So f of g of x equals -8/5 x plus 1. 7 minus 6 plus 1. Okay, number 15. So I'm going to erase this. I just wanted to show you that. Number 15, I'm going to put f into itself. Okay, so I'm going to take 7 minus 2x and I'm going to put it into this x. Okay, so I have 7 minus 2 times, and I'm going to put 7 minus 2x into that. So again, distribute the 2, -2. 7 minus 14 plus 4x equals 4x minus 7. And I'll put f of x out front. Okay, number 16. I'm going to take f of x and put it into h. So here's my whole h. So I'm going to put f of x into the h. So 2 times 7 minus 2x minus 13 divided by 2. So distribute the 2. 14 minus 4x minus 13 divided by 2 equals negative 4x plus 1 divided by 2. And I'm going to leave it like that. H of f of x equals that. Number 17, we're going to take the h equation and put it into the f. So f is 7 minus 2, and then in place of x, I'm going to put 2x minus 13 divided by 2. So the 2's cancel. This 2 and this 2 can cancel. So now I have 7 minus 2x minus 13, which equals 7 minus 2x plus 13. So negative 2x plus 20. And I'll put f of h of x here. Ooh, sorry. Okay, and number 18. Now this one has a number here, so I'm going to take 10, I'm going to put it into g. Okay, so the g equation is 4/5 x. So instead of x, I'm going to put 10. Okay, so this is 5 goes into 10 twice, so 8 plus 3 is 11. Okay, now I'm going to take 11 and put it into the f equation. So 7 minus 2 times 11, which is 7 minus 22, negative 15. Okay, number 19, determine whether the functions are inverses of each other. Prove algebraically. So in order for them to be inverses, here's what I need to prove. F of g of x has to equal x, and g of f of x has to equal x. Okay, so this is what I'm looking for. So on 19, f of g of x. So I'm going to put g, this whole thing, into f. So negative 4 times x minus 13 divided by 4 plus 13 equals. So these 4's cancel. I have this negative I'm going to distribute. So that becomes negative x plus 13 equals negative x plus 26. This did not reduce to an x. So because it didn't reduce to an x, it's not a function. I'm sorry. They're not inverses of each other. Okay, so as soon as I get to this and I realize, oh, I didn't get x, I'm done. Stop. Okay, so let's do this one. So I'm going to do f of g of x first. So I'm going to put this whole thing into this x here. Negative 2 times negative x minus 5 divided by 2 minus 5. The 2's cancel. Okay, be careful this negative sign. I'm going to distribute. So positive x plus 5 minus 5. Those cancel and I get x. So that worked. Okay, you have to check the other one. So now I'm going to do g of f of x. So I'm going to go the other way. I'm going to take this whole thing and put it into this x. So negative, be careful of that negative sign right there. Negative 2x minus 5 divided by 2. So distribute the negative becomes 2x plus 5 minus 5. The 5's cancel. 2x divided by 2, those simplify and I get x. So yes, these are inverses of each other. Number 21, find the inverse equation for each function. So first thing I'm going to do is switch x and y. X equals negative 3y plus 2 divided by 5. I'm going to get y by itself, so multiply by 5. 5x equals negative 3y plus 2. Subtract the 2. 5x minus 2 equals negative 3y. And divide by negative 3. So y inverse equals 5x minus 2 divided by negative 3. 22, switch x and y. X equals 2/3 y minus 3. I'm going to add 3 first. X plus 3 equals 2/3 y. Okay, if you have a fraction in front, multiply by the reciprocal. So times 3 over 2 to the whole thing. So over here, times 3 over 2. and I'm going to distribute that. So y inverse equals 3 over 2x plus 9 over 2. Here's my inverse equation. Okay, number 23. Describe the transformation from the parent and graph and give the domain and range. Okay, so first of all, I know that the parent function is y equals square root x. So I'm going to draw the parent function first. So 0, 0, 1, 1, 4, 2, 9, 3 if you want to add an extra point in there. Okay, make sure you know your parent functions. Okay, inside the function, so under the square root, this is moving right. So horizontal shift right 4. Okay, I'm going to go ahead and do that. I'm going to take each of those points and I'm going to shift them right 4. 1, 2, 3, 4. And there's that one. Okay, so there's right 4. And then the plus 5 on the outside makes it move up 5. So vertical shift up 5. So I'm going to take each of those points, the green ones already moved, I'm going to go up 5. Okay, so the blue one is my final graph. Okay, it also says give the domain and range. So the domain, I'm looking at the blue graph. My farthest left value, so domain, my farthest left value is positive 4, bracket, and it's going to the right with an arrow, so that's a positive infinity. Okay, range, my lowest y value is positive 5, so bracket, and going up to infinity. Number 24, my parent function is absolute value of x. So I'm going to draw that first. 0, 0, and then up 1 over 1. Draw a few. Again, make sure you know your parent functions. Okay, so there's nothing on the inside. That's what you would do first. So then I'm going to do this. Remember, this is two different things. So it's a vertical stretch by 2. And it's also a reflect over the x-axis. Okay, you can do this all at once. So remember, I'm going to multiply the y values by -2. If you are struggling with this, make yourself a little table of values. Okay, so I'm going to put these points on there. 0, 0, 1, 1, 2, 2. Multiply the y values by -2. So this stays 0. This becomes -2 and -4. So now I have 0, 0, 1, -2, which means I also have the opposite, and 2, -4, which means I also have the opposite. Okay, so that right there was the negative and the 2 at the same time. Okay, the very last thing you would do is then this -3. So that's a vertical shift down 3. So I'm going to take each of those coordinate points. Sorry. Oh, that's right. Vertical shift down 3. So I'm going to take, let's see, blue. 1, 2, 3. 1, 2, 3. Oh, sorry. Well, ignore that extra blue dot. Okay, so domain and range. So I'm looking at the blue one. Okay, domain. These arrows are going down, left to right. This is going out to negative infinity. This is going out to positive infinity. So negative infinity to positive infinity, or all real numbers. Range, we go bottom to top. These arrows are coming from negative infinity. And then what's my highest y value? My highest y value is -3. So I put -3 and I put a bracket. Okay, 25, my parent function y equals x squared. So I'm going to graph that first. 0, 0, 1, 1, 2, 4, and graph the opposites. So it looks like that. Okay, so first thing you would do is the 6 on the inside. That's going to make it move left 6. So we say horizontal shift, left 6. Okay, I'm going to do that first. So everything goes left. 1, 2, 3, 4, 5, 6. Okay, secondly then is what's out in front. Okay, this is less than 1, so vertical compression by 1/4. If you are having trouble with this, you're multiplying the y values by 1/4. Again, make that table of values, x, y. So I have -6, 0. I have -5, 1, and I have -4, 4. Okay, I'm multiplying the y values by 1/4. So this stays 0, this becomes 1/4, and this becomes 1. So now I graph those. -6, 0 stays. -5, 1/4, and -4, 1. And then you have the opposites, so here and here. So you see that the parabola got flatter or wider. Okay, and then the last thing you do is this +4. So this is a vertical shift up 4. Okay, so I'm going to take, what color do I need? Pink. I'm going to take my blue graph, I'm going to go up 4. 1, 2, 3, 4. Then I have this 1/4 mark. So up 4 puts me right here, and then this one's at 1, so it puts me at 5. Okay, so the pink one is my final answer. So the pink one's the one I'm going to look at for domain and range. So domain, I have an arrow to the left and an arrow to the right. So this is -infinity to +infinity, or all real numbers. Range, bottom to top, so my lowest y value. The lowest y value is at +4, so 4 bracket to infinity. Okay. All right, last page, 26. So where is it increasing? So remember, increasing is kind of like a positive slope. So this is increasing, and I go from left to right, it's actually increasing the whole time. So on increasing, I'm going to put -infinity to +infinity. So because it's increasing, it's never decreasing. Where is it positive? Positive is where the graph is above the x-axis. So here, all the way up, and it keeps on going. So it's starting right here at 0, 0. So remember, positive, negative, all these 4 actually, all get parentheses, never brackets. So starting at 0, going up to infinity. Okay, and then where's it negative? It's negative below the x-axis. Okay, it's coming from -infinity up to 0, parentheses. Okay, the second one. So where is it increasing? Okay, it's increasing here. It's going uphill right here. And it's also increasing here. So the first one, right here, remember you're looking at the x value. So that x value is -3. And it stops increasing at 0. So -3 to 0. And then this one starts at +3, and it's going to go on forever, so infinity. Okay, then decreasing. So this is decreasing, and this is decreasing. So our first decreasing interval starts at -infinity and stops here at -3. And my second one starts at 3. Starts at 0. Starts at 0 and switches at +3. So negative infinity to negative 3, and then 0 to 3. Okay, positive. So positive again is above the x-axis. So be careful because these arrows keep on going. So it's positive there, it's positive here, and it's positive here. Okay, so 3 spots. And there's not a lot of room. I'm going to come down here. Okay, so this one is coming from negative infinity, and it switches at 1, 2, 3, 4, 5, negative 5. Okay, this piece picks up at negative 1.5 right here, and it's positive all the way to positive 1.5. And then 5 right here to infinity. Okay, so 3 places where it is positive. So then negative is below the x-axis. So, sorry, I used green twice. So it's negative here and here. So this one starts at negative 5 and goes to negative 1.5. And this one starts at 1.5 and goes to 5. Okay, so there's your positive and negative. Okay, number 27. A theater sells tickets for $22. If you pay by credit card, they add a service charge of $3.50 to the entire order. Okay, so write a function that gives the amount billed to the credit card as a function of the number of tickets. Okay, so we have amount is equal to, so $22, I'm going to use n for number of tickets, and then they always add $3.50. Now, because it's a function, we say a of n. So kind of like when we do f of x, I'm going to use amount. Okay, so it's a real world situation, which means really I'm just going to solve for this variable right here. Okay, so over here, I'm going to use just a for now. And I'm going to just solve for n. So I'm going to subtract $3.50. And then divide by 22. So n equals a minus $3.50 divided by 22. Okay, so this, it says write the inverse function. This is the inverse function. Then it says use it to find the number of tickets purchased when the credit card bill is $157.50. So this is the amount. So I put that in for a. So n equals $157.50 minus $3.50 divided by 22. And you're probably going to calculate for that. So n equals 7. So 7 tickets purchased. Okay, and then the last one, is it possible to have a total of $322.50 billed to your credit card? Why or why not? So I want to look. N equals $322.50 minus $3.50 divided by 22. And when I got this, or I put that in my calculator, I got 14.5. So I said no, because you can't buy a half ticket. Okay, last section, number 28. We're going to take that function and reflect across the x-axis. So across the x-axis is negative f of x, which means I'm going to multiply the negative to the whole function. Okay, so I'm going to put a negative up front of just the whole thing. And it distributes. So it's going to go into, so this distributes. It goes here and it goes here. So g of x equals absolute value x plus 2 plus 4. Okay, number 29, vertical stretch by 2. So that's c times f of x. So it gets multiplied to the whole equation. So I have 4 times x plus 2. So I'm going to distribute. So g of x equals 4x plus 8. Number 30, reflect across the y-axis. So across the y-axis is where it just touches x. Okay, so on the inside, the only thing that changes here, g of x equals, this becomes a negative x minus 5 plus 2. The only thing that changed was the x. 31, vertical compression by 1/2. This is the same as 29, c times f of x. So I'm going to multiply 1/2 times 4x squared plus 6 and distribute. So g of x equals 2x squared plus 3. 32 reflect across the y-axis. So across the y-axis, the negative touches x. So g of x equals square root negative x plus 11. And the last one, 33, vertical shift 3 up. So when I'm moving up and down, it goes outside the function and it stays the same sign. Okay, if it was a, let's say, square root x, if it was a horizontal shift right 3, okay, that would be f of x equals, oh sorry, that should be g of x equals square root, and since I'm going to the right 3, I'm going to use the opposite sign, so it'll be under the square root. Okay, so make sure you don't get those confused. All right, that's it. Hopefully this helps you out. If you need more help, make sure you come and see one of your teachers.